Alright, so I want to help you out with some of the even problems that are kind of near what you're doing for homework. You've got the odd problems for homework, and so if we go over some of the even ones, maybe that'll help you with what we're doing with the odds. The first one here, this is number 16 on page 8, and it's want to know which quadrant solves these two inequalities. So we've got x is less than 0 and y is less than 0. Remember, this is our positive x-axis, and over here is our negative x-axis. And then we have the positive y-axis and the negative y right here. So for x to be less than 0, it's got to be to the left of the y-axis. So you can think about it as shading in this. Any point you pick over here, your x value, your x coordinate, is going to be negative. Same thing for the y. We want y to be less than 0. So it's going to be below the x-axis. So anything below here, you're going to get a negative y-coordinate when you look at any of these points. So we want one that satisfies both conditions. That's where the green and the purple overlap. So remember how we label our quadrants. This is quadrant 1, 2, we're going counterclockwise, 3, and 4. So our answer is going to be quadrant 4. Not quadrant 4. What am I saying? Quadrant 3. Alright, let's take a look at the next one. So here we've got x is greater than 2 and y is equal to 3. So for x to be greater than 2, we can kind of think of it as, I'll draw a line. Right here is x equals 2. Oh, my computer's lagging on me. Let me try that again. I'll just draw it by hand. It has a hard time with that. So x equals 2 will go down right through here. Sorry, I know they had a much better line. Pretend like that goes through x equals 2. And so it's everything to the right of this is going to be greater than 2. Any point you pick, your x value will be larger than 2. But then we have y equals 3. So we want points that are going to be including y equals 3. Notice that anywhere along this line, this is the line y equals 3, any point you pick on that blue line is going to have a y value of 3. So we're not so much concerned about exactly where the point is, it's just what quadrant does it have to fall in if your x value is greater than 2, for instance 5, and your y value is 3. What quadrant must 5, 3 be in? Well, it must be in quadrant 1. And any other point you pick where this value right here is greater than 2 and this value is definitely equal to 3, it's going to always end up in quadrant 1. This one just says x is greater than 4. So our x value, 1, 2, 3, 4, once again, if we draw the line x equals 4, we know that any points to the right of that is going to give me a value or an ordered pair where I have an x greater than 4. So it could be 4, 10, which would be, well, it wouldn't be 4, 10, 5, 10, because it's got to be greater than. So it could be somewhere over here, 5, 10. Or it could be 5, negative 2, or it doesn't have to be 5, it could be 20, comma, negative 7, or so negative 6. So I'm already writing a 6 there. Either way, it's going to end up in either quadrant 1 or quadrant 4. So our answer is quadrant 1 and 4 here. Negative x is greater than 0 and y is less than 0. So we've already done our y is less than 0 with the first example. So y is less than 0 is going to be anything below the x-axis. I'm just going to shade all that in. And then this is a little bit trickier. X is greater than 0. Well, you could think of it as if you multiply both sides by a negative 1, you get x. And remember, when we multiply this side by a negative 1, we still get 0, but it flips the sign. So anytime, remember, when you have an inequality, like negative 5x is less than 15. If you multiply or divide both sides of the inequality by a negative number, you have to flip the sign. So you get x is greater than negative 3. We're going to do the same thing here. So basically it looks the same, except for you lose that negative, but the sign has to flip. That's the key there. So if I shade that in, anything where x is less than 0 is going to be to the left of the y-axis again. And the overlap here is in quadrant 3. And so we have one more here, x, y is less than 0. So let's think about what are possible values for x and y. If they were both positive, what would you get? A positive times a positive, which equals a positive. Well, a positive number is always greater than 0. So they both can't be positive here. What if they were negative? If they were both negative, you'd end up with a negative times a negative, which equals a positive. Well, once again, positive is greater than 0, not less than 0. So in this case, x has to be positive and y has to be negative, because that gives you a negative. Or x has to be negative and y has to be positive, because a negative times a positive is a negative. So these right here are situations we have to look at. Either x is positive and y is negative, or x is negative and y is positive. So if x is positive and y is negative, think about our quadrants here. Here we've got positive, positive. Both of these guys are positive, both the x and the y. Here we've got negative, positive. Here is negative, negative. And here is positive, negative. So the two quadrants where they're both both positive nor negative, or you can think one's positive, one's negative, is quadrant 2 and quadrant 4. So that's where we get, when you multiply the two, you get a number that is going to be negative or less than 0. So quadrant 2 and quadrant 4 are going to be our answer here. Well, hopefully going over a few of these helped you with the odd problems, and let me know if you have any questions.